Uh, Good morning, everybody. I want first of all say thank you to my Albanian colleagues out of the kind invitation, and then we are group is come from. I think there is a sort of return of sound. You should put low volume somewhere. Mm. And then I say thank you because there is very good. The organization is very good, and also these large and broad panels are very interesting. Also, the speaker that talked before me talking something related with my topic. The difference with the Professor Papayorgu, you should be patient with my Broccolino South Italy accent, and I will try to be clear in my presentation. The presentation is related with the problem of infrastructure. We can say bridges, tunnels, and so on. Construction on the territory, and they take advantage of new technology, IOT technology. It means communication of the data on the internet. We know that we are very accustomed with this kind of structure, so with kind of tools. Alexa is very famous. It's a sort of a black box that gives us some idea of very powerful contents of knowledge, or like encyclopedia or something like that. So internet is becoming very appealing and attracting field for many kind of use. We can say that this is mostly to the miniaturization of things, very affordable. The cost is very limited, and we can imagine that everything we can put some little we can say little spy of the health of the structure, and then we can monitor not only the temperature, or we can not only turn on off the heating system, just not for domotic, but we can spread the use of the IoT in several places, several applications. So in this case, we can see here there is a sort of application in the structure. Let's go now to the main topic we are just dealing today with. And this is related with infrastructure. Here we are in Italy, and then we see here some example of damage of the bridge. So you see here bridges under here, or here, or here. There is a sort of saddle between two parts of the bridge. So this is very important place of the bridges need to be monitored. And then also we say here we are in Albania. We can see some very famous bridge. I imagine you know this kind of bridges. This is Pustri Bridge, and also we have another bridge here, Lekli Bridge. I took this information from a report, a large report from Albania, from Albanian Road Authority in 2019. You should put a little bit lower the speaker. So now you look here, we have the typical decay curve. It means that when we are here in our life of structure, we are at beginning of the horizontal moment where there is an initial level, and if we go too much down, we can reach we can go under the level of the acceptable safety, and this is a level of attention. So if we imagine that the life will go little by little, will be some decay, then we need to improve suddenly with some maintenance work the safety of the structure, and then will be again another decay and so on. So we already should follow this kind of curve. It means that we need to perform such kind of monitoring. Now there are several devices available for monitoring bridges, and here, for instance, there's in Stockholm, there is a bridge that has been fully equipped with IOT device. And here there's another bridge in Stockholm. It's 1925, so pretty old, still bridge. But even there's here some tools to collect the energy from the bridge movement and then to give power directly from him to the monitoring system. And then here there is a stress history at the passage of a train on a bridge. The structural people, they know what I mean, because here is exactly the stress inside of the bridge, inside of materials when one bridge is passing by. So it means that if we have, for instance, one bridge, and you can imagine here, this is Manhattan Bridge in New York. You see the movement here. You see the passage of the subway here. They make some movement. The structural engineer, they want to know exactly in that moment, in real time, what is the stress here inside the bridge. And this is very, interesting approach, and this is what we want to do in our work. So what we suggested to have a very good system to monitor the structure and make not only accelerometers that most of the time they could not give you many information, but we put also strain gauge, we made a deformation system, or temperature, or corrosion control, carbonation control, and then all this kind of information will be collected by router that we put it, so by Wi-Fi, so by this kind of, we can say IoT system will be collected by each span of the bridge, for instance. And then will be a long fiber cable, one armored fiber cable can collect all along the bridge the information, the data, and then will be sent away from a big wide network system. And then we can have also protection from possible, we can say, electromagnetic pollution given by the cars, the vehicles running on the bridge. So we can make a sort of a hybrid solution. One is a local, is like with IoT, so Wi-Fi, and general collecting the data is data given by this kind of fiber fiber cable. This is the fiber is just for communications, not for deformation or control of stress. And this is a typical, picture of how can be dressed with all these kind of tools, our bridge, our structures. So we want to put just inside of the structure some elements that can give some sensors that can give us the idea how good is that moment, the structure, or if something happened in some moment, we can also recover it with a sort of log, a sort of a record of the event, what happened there. So finally, what we can say that the IoT system even applied to the structural health monitoring for infrastructure, it give us very good control of the safety of the structure. Also, the fact that it's very affordable and they are so small object is very encouraging large diffusion of such kind of tools. And one is very important is the costs are very limited, very reduced. But contemporary, we also reduction of the cost for the maintenance, because if we control any moment the life of the structure, and then if we have some knowledge about the level of damage in some place, we don't need to reach the limit moment to make big work and maintenance work, but we can just make some good immediately work. Disadvantages are that all these kind of tools, these are electronics tools. We need to make a very good plan, very good design of this kind of architecture, and then we need to face with some reliable bridge management system. So one software that will control, even with the help of artificial intelligence, to control all this data, because this kind of big data, as we also heard before, are very important. Could make you confused about what happened there. So we need also to make very synthesizing the results. The other risk is also that someone not structure engineer could imagine that we should just using this kind of tools, they can control without any engineer judgment the structure. But this is wrong. This is just a tools, and then we need to always some engineer structure. So we want to control the structure, the infrastructure, all our structure, like we control the car. So we want to have a permanent control in real time, in every moment, what happened there. We want to definitely be far away from very dramatic situation that happened also in Italy recently, for instance, with the collapse of the bridge in Morandi Bridge in Genoa. Thank you very much.